All right. Okay. Let's get started. Hi, everyone. Yeah, welcome to using MySQL Clone Plugin in MySQL 8.0 for physical copies at scale. I am Akshay Suryavanshi, production engineer at Meta.
I'm Chun. I'm a software engineer at Meta.
Okay. So in today's talk, we'll look at like how we do physical copies of MySQL databases at Meta. Then we'll learn something about like MySQL Clone Plugin, what is it, and like how to use this clone plugin, and how we added support for MyRocks in Clone Plugin. Then we'll discuss about the automation that we wrote to use Clone Plugin for copying processes. And finally, we'll look into performance and reliability of the cloning process. And at the end, if we have a few minutes, we'll go into questions as well. Okay, so physical copies of MySQL databases at Meta. So first of all, like all of these slides are made by a human, no ChatGPT here. So if there are any mistakes, then it's ours. So MySQL infrastructure at Meta relies heavily on physical database copy tooling. I can give you some use cases that where we use database copying. For example, like the most common use case is if a replica breaks due to a fatal replication error, or its underlying hardware dies for some reason, then we would want to replace that replica. So we use physical copy tools for making that replacement happen. We also move data around our data centers and various racks where they are. This could be done for basically conducting disaster storm scenarios, like draining a whole region, or like even as simple as like servicing a rack. Then we also use physical copy tooling for balancing sort of host utilization. So imagine like a single host, there is an instance on a single host, which is sort of about to become a noisy neighbor or can become a noisy neighbor or cause the space overflow issues. So we would want to move it on a host where we have enough spare capacity for that particular instance to grow. So again, use copy tooling for such cases. Finally, like one of the most important use cases is building staging and testing environment from scratch. These environments need to be refreshed recurrently, and for that we use physical copy tooling, copy data from production, build up these staging environments really fast. So as you can see, like at the scale that we operate and the number of use cases that we have seen, we require our physical copy tooling to be really fast and robust. So for physical database copies, we currently use Percona Xtrabackup. Xtrabackup works both with InnoDB and MyRocks, which both we run at scale. So Xtrabackup is invoked by our self-healing automation tool or system called MPS. MPS is basically it's a name for MySQL pool scanner. It's again, as I mentioned before, the instance movement. It's all taken care by this particular system. So the main ingredients of copy which are done by MPS are we use XB stream as the copy format. So the Xtrabackup copy is never in one place. It's always moving from one instance to another. Then we compress that stream using Z standard. So there is Z standard compression used because we don't want to copy like terabytes of data like hundreds of times a month. Then we use encryption or a socket pipe, the pipe through which the XB stream is getting copied to another host. So these are the moving parts in the copy process. A little bit about MPS. MPS also doesn't just invoke Xtrabackup and like say that copy is done. It also does something called as topology level locking. So we don't want multiple physical copies occurring on the same sort of cluster. That would be sort of like draining the source instance of resources in this particular case. So we try to avoid that with some locking, and that's done by MPS. We also tune these copies heavily. So based on the hardware that is used, the region that the copy is happening in, we want to ensure that not all copies are blazing fast. We don't want to burden our network infrastructure or the hardware where the copy is occurring from. So we heavily tune them. Which means like we set copy speed, do not go beyond this particular speed, and the copy tool try to adhere to that particular limit that we have set. MPS also does something called as data correctness, which is basically just verifying if the data that is copied from source to a destination is actually correct. We don't really want to have any surprises that yes, we have been running this copy tooling for a long time and it has been already always introducing some corruption. And the way to find corruption is actually comparing data between these two instances. MPS finally also does replication setup. So we don't just copy data. We want to bring that instance into production, and that way, like the whole copy workflow is completed. So MPS will basically see if there are bin logs available for that replica to catch up. If not, like pull bin logs from the backups and like do the catch up. So this is a very, very simplistic high-level view. This is how instance movement looks like. So for some terminology, we have a replica set, which I was referring as cluster here. Replica set is basically, imagine it as a MySQL cluster, not a group replication or some sort of like NDB cluster, just a group of instances replicated using semi-sync replication and asynchronous replication. So that's a replica set. A single host can have multiple instances running in them, and each of these instances belong to a specific replica set. So that's the stacking that we sort of see in our environment, and that's why we keep moving instances from one place to another as demand increases or decreases. So let's take a look into like how like actually MPS copy workflow happens. Again, at a very high level, we start by allocating a host where the instance that is supposed to be created, the resources required by that instance are present, which means like it has enough memory, enough storage, and enough CPU so that we can start copying the instance. MPS basically, after that, starts installing a MySQL version and release that the copy expects. So we try to ensure the production version is present, and then we sort of like set up the ACLs, access using grants and stuff. Once the destination instance is set up, then MPS will start copy using currently Xtrabackup. And as you can imagine, like overall in this whole workflow, this is going to be the lengthiest step. And this is where we see bottlenecks happening, like why this copy is taking 2 hours, 3 hours, or n hours. It's mostly around like Xtrabackup and the size of the data that is getting copied. After the copy process is completed, we, again, as mentioned before, MPS sets up replication, and then we finally have an optional step of data correctness. So it's not possible to do data correctness every time, given just the number of copies that happen on a daily basis. But we do try to like sample every now and then. If we are introducing a new tool, a new version of Xtrabackup, we do ensure that. So when data correctness is invoked, it becomes the lengthiest step. We are comparing data logically, so it scales with the number of rows that we are trying to compare. And finally, MPS gives the finishing touches, like puts that instance as discoverable, and now the instance is part of the replica set, and the whole maintenance operation is finished. Okay, so John will go into the MySQL plugin.
Thanks, Akshay. Okay, I'll talk about the MySQL Clone Plugin. So MySQL Clone Plugin was introduced in MySQL 8.0.17, and it generally allows a recipient instance to physically copy data from a donor instance by using clone protocol. Compared with other methods of creating copy, MySQL Clone has several advantages. First, it provides better performance. Secondly, we ran into issues with concurrent DDL in Xtrabackup, and we believe the MySQL Clone has a better support for it. And thirdly, so by using MySQL Clone, we eliminate the need to ship Xtrabackup as a separate software component and only need to ship MySQL binary. So it will reduce the software dependencies in our production. However, there are some drawbacks to using the clone. We need to integrate MyRocks with MySQL Clone Plugin, which involves new and untested functionality, and it may introduce some risk or some risk in our production. And the MySQL Clone, it only supports copy across the same milestone release only. So these are some drawbacks. So MySQL clone can be initialized by simply run the clone instance from the command line, and the user can set some configure some settings like the valid donor list or some global clone-related system variables. And after running this command, the clone process will start automatically. So this figure gives us a broad overview of what happens in the MySQL clone. Initially, the client, which is the recipient, it will send a command to the donor, and this occurs over the network via the clone protocol. And then the donor will send the data back to the client over the network, and that's simply it. So the MySQL clone, it only supports InnoDB storage engine, which means tables belonging to other storage engines will be copied as empty tables. However, at the Meta, MyRocks is the most common used storage engine in our production. So it is necessary for us to extend the support to MyRocks storage engine. During the extension, we have some challenges in various aspects. So the first aspect is about the development. So now we need to support 2 transactional storage engines rather than a single one. And there's a huge gap to fill. And the second aspect is relates to testing. So at the Meta, MyRocks is running at a very large scale. Even very rare bugs are likely get hit in production. So we need to make sure our testing are very rigorous to cover as many issues as possible. And the last aspect relates to the automation integration. So basically, it's about the migration from Xtrabackup to Clone Plugin in the production. And I also want to give a shout out to Larinas for the design and development for MyRocks Clone Plugin. Larinas also provide most of the design slides, so shout out to Larinas. MyRocks clone is an extension of MySQL clone. So to better understand what MyRocks clone did, let's get started with the MySQL clone internals. We'll cover the locators, the clone storage engine API, the data copy, and the threading. MySQL clone locators is basically a logical pointer to the data snapshot, and it is storage engine specific. So at the beginning of the clone, a dummy locator will be created for version negotiation between the client and the donor. And as a case of clone restart, the client locator will be used as a snapshot to tell the donor when to restart. This figure gives us a closer look at about how clone works in general. So the clone process can be simplified into 3 phases: the preparation phase, the copy and apply phase, and the end phase. So for the preparation phase, which corresponds to the first arrows, it basically did some initialization stuff. For example, the donor will create the snapshot, the client will create some clone-related directories, and the version negotiation also happens in this phase. Moving on to the copy and apply phase, so which corresponds to the middle 4 arrows. Yeah. So in this phase, the files in the disk and the buffers in the memory will be transferred from the donor to the client by calling some callbacks in the plugin, in the clone plugin. And for the last phase, which is the last 2 arrows, it basically did some cleanup works and tells the client to restart itself after the copy has finished. So the data copy is a main step in the whole clone process, and let's dive more into it. So once the client is ready, it will tell the donor to start the copy phase of the data transfer phase. So the clone plugin has some callbacks which the donor can call into for transferring the data descriptors and file chunks. The donor will call these APIs, these callbacks, and then the data descriptors and the file chunks will be translated into clone protocol and get sent to the client. Once the client receives this data, it will it will apply them accordingly and send an acknowledge back to the donor. Then the donor can proceed with sending the next chunk of the selected file. And that's basically what this figure talks about. MySQL Clone also supports multi-threading, and it is like to enhance performance. So initially, a main task will be created for handling some initialization stuff. Then additional threads can be spawned based on the user's requirements. So for example, the user can specify like how many threads, the number of threads it wants to utilize, or it can turn on the auto-tune concurrency feature, so which will let the client decide how many threads it needs to spawn based on some target speed, target transfer speed. The above are some background and context about the MySQL Clone internals, and with this background, let's move to the MyRocks clone and talk more about it. So we'll cover the checkpoints, the data structures in MyRocks clone, and the cross-engine synchronizations between MyRocks, InnoDB, and the binlog, and some error handling and crash recovery. So MyRocks checkpoints are basically snapshots for databases, and it is implemented for backing up MyRocks instance and is used for physical copy. So the data copy in MyRocks clone is based on the checkpoints. Basically, it transferred everything in that checkpoint, including the SSD files, the WAR files from the donor to the client. Since the data files are immutable, so the checkpoints can simply be done by hard link all of the data files in a separate checkpoint directories. And it is very easy to do that. And like even for the databases have some data changes or there's some compactions, the checkpoint doesn't change. Cool. So MyRocks clone, it implements the rolling checkpoints to speed up the recovery process in the client. It is achieved by creating new checkpoints periodically. So the new created checkpoints will include the newly generated SSD files. And so like for the client, the closer it to the donor's final production status, the less transactions it needs to catch up and the faster and more efficient the recovery process can be. So this figure gives us an example of 3 checkpoints in one clone. So we can see like compared with the first checkpoints, the third checkpoint has more information about the donor status. So after the additional stats is sent to the clients, it can help the client to relieve the burden of catch up the gap to the donor. So we have some new data structures in MyRocks clone. And so this figure gives us an overview of what kind of information is transferred from the donor to the client. In general, there are 4 types. The first, like we have information about the list of files in the checkpoints. We have information about the metadata of the file being transferred. There's also data chunk itself, and there is some estimation of the amount of data has been transferred to the client. Yeah, you can see like 4 arrows corresponds for different types. And from the donor side, so we have some structures to track the files that have already been sent. Those are pending transfer and the ones that are currently in progress. We also have an active task ID list. This is just some like the active running threads on the donor. And on the flip side, in the client, we have structures to track how many, like what has been received, what has been applied as a file. And we also have the active task IDs, which is basically the active running threads from the client side. Okay, let's talk about the cross-engine synchronization. So this figure is about InnoDB. So in InnoDB, it has three phases. We have the copy of the file, the copy of the page in the buffer, and the copy of the redo logs. So the synchronization between the InnoDB and the bin log happens in between the page copy and the redo copy. And I want to know that, so the synchronization here is purely performed inside of InnoDB. So now we know that the synchronization happens in InnoDB. The InnoDB and bin log has already synchronized, but we also want to synchronize MyRocks with them. So what can we do? Here is the changes we've made to make sure that the synchronization happens among three engines instead of just two. We make use of the performance schema log status table to get the synchronization information and of all three engines, and this information will be used as synchronization point later. We add a new handler-turn API called clone set stop at log positions. So this function call is meant to, given the log status information, tell the engine what the cutoff point of the log is. We also add one more phase called SST copy phase. So we add this phase in between the page copy and the redo copy, and the synchronization point happens right after the SST file copy. So let's see some visual representation of these changes. So now effectively we have four stages. The file copy and the page copy is for InnoDB. The SSD copy is for MyRocks, and the redo copy is also for InnoDB. The file copy and page copy remain the same, but after the page copy, there is a callback which goes back to the clone plugin, and then it will call into MyRocks to start the SSD copy. Once the MyRocks finishes the SSD copy, it will return back to InnoDB and finish the redo copy. And we can see the synchronization point happens in between the SSD copy and the redo copy. So actually in the code, it will start in between the SST and the redo copy. So we can get the synchronization point by querying the log status table, and we can set the log stop point by call the clone set stop at log position function call. Let's talk about the error handling and crash recovery. So the clone can handle network failures. If it detects there's a network failure, it will resume the clone by using the locators in the client. And there is a file marker in the client. So when the client, during the client startup, once it detects the clone in progress file marker, either in the data directory or the temporary data directory, it will abort the startup immediately. It will also clean the checkpoints directories during startup.
Okay, cool. So yeah, let's look into how we wrote on the automation to leverage the MySQL Clone Plugin now. So as we started working on writing tools to use the MySQL Clone Plugin, some preliminary configuration setup was needed to be done. So first of all, we decided to install the clone plugin from MySQL release 8.0.28. This was done to ensure that the concurrent DDL support, which was added to MySQL Clone Plugin in 8.0.27, was included. So without the concurrent DDL support, basically, if you're running a clone operation, an online DDL or any DDL will basically try and block. This is because the clone operation takes a DB backup log, and that backup log is going to block a metadata log, I believe, in this case. And similarly, if you are running a ongoing DDL, like some alter table statement, a clone operation on that particular instance is again going to block. Again, same reason, it cannot acquire the instance level backup log for the instance. So Oracle basically fixed this, and now we have the support to run concurrent DDL. While rolling out the MySQL Clone plugin and the MySQL release, we also added a few changes like setting up the SSL configuration. Clone has its own SSL configuration, so you can have encrypted copies. and other non-default values that we wouldn't want to do on runtime configuration. And as we mentioned previously, since we want to tune, like MPS wants to tune the copy speed based on like the network and hardware constraints, we basically leave the clone auto-tune concurrency variable on. We do not try to configure like the number of threads that the clone should have. The reason for doing that is because just the diversity of the hardware and the network setups that we have, just mapping that anywhere in some configuration, that 16 thread for this, 12 thread for that, it's not really feasible. And we trust auto-tune concurrency. It works and tries to use the multiple threads. So for the tool itself that basically calls the clone instance from command, so in MPS, wherever it called Xtrabackup, we basically wrote a tool to call it the clone instance from command and do some runtime configuration for that cloning, like setting the copy speed and all that. Since InnoDB and MyRocks both use the same API, when MyRocks development was happening, like we decided that it will use the clone instance from command. It made our job easier to basically start writing the automation as the MyRocks development was happening. This way, like when the MyRocks development was done or we were ready to test, we could just use automation to start testing the new sort of functionality. On the monitoring side, a lot of existing MPS monitoring for physical copy was already used. We added some local monitoring to the clone tooling that we created. This local monitoring is done using the clone status and clone progress table in performance schema. These tables are only populated on the recipient. So we have to query them from the recipient side. On the donor, they are not populated. So clone status, as the name suggests, is basically telling you the status of the ongoing clone operation. So if the clone operation has started, finished, errored, or failed, or like finished or completed. So we use this particular table to sort of determine if the copy process has completed or not. We don't have to do any sort of like process checking or anything that we would do to understand if a Xtrabackup or any other such external tool has completed. So just internally query a MySQL table. The clone progress table is, again, as the name suggests, shows you the progress of the ongoing clone operation. This is also helpful since clone is divided into a number of steps, like dropping the existing data on recipient, doing a file copy, page copy, redo copy, restart, and recovery. There are many stages. You could basically get timestamp start and end timestamp of all of these stages from the clone progress table. And there are two benefits. When I'm debugging a clone operation, I know what the last stage was and what the current stage is and how much longer it was in that particular current stage. Sort of help in like creating a mental map as like where it must have failed. Secondly, like if we were to tune the cloning feature in future, we could basically see like, okay, what part of the cloning process can be tuned? Is it the page copy that is slow? Is it the file copy? Can we make it sort of like more faster? So this kind of visibility is actually very helpful. One more important thing that we did was basically keeping the session which executes the clone instance from command from our new tool to the recipient. We decided to keep it open. We don't have to. We could basically just kill that session and pick up the progress of the clone from the clone progress table or the clone status table. But we decided to do that. We did that using netwit timeout, a very large value for it. And the reason is like if we were to cancel the clone operation, we would want to reliably cancel the session and via that session, the clone operation. If clone returned an error, we would want to reliably bubble up that error in the logging for the tooling. So that way we basically have insight into what something failed in one log file rather than having to go and dig into MySQL and try to find that error. And so that better exception handling is the reason why we try to keep connection. Again, it's not necessary. You could basically leave that connection can get idle timeout or something like that, and the clone process will keep running. To counterintuitively, we don't want to do that. We want, when the tool cancels, we want the clone to cancel. Otherwise, we'll just have like thousands of like clone operations running without knowing what tools are calling them. Okay, so we also moved some of the tuning capabilities that we currently do with Xtrabackup externally into the MySQL server because clone is available in the server itself. We could move some of these tuning as well. So one example of such tuning is again as we saw like previously the number of scenarios in which we use copies. Some of the scenarios are sort of like best effort or low effort. Okay, so we want to propagate this kind of like quality of service expected from the copy process to the actual copy process. With Xtrabackup, it is easier to do as we can sort of like set a quality of service field on the socket pipe, and that socket pipe will ensure like how the packets are delivered. So one use case I can explain you is imagine there is a network degradation event happening in some region, some DC. In such cases, we would want the packets related to the copy, the physical copy, to be dropped. It could be a maintenance-related copy if it is a low priority or best effort. So we want to drop those packets in favor of something which is client traffic, actively serving production traffic or replication traffic. So this is where the use case comes in. So we added a configuration variable to allow to set this quality of service type. We do that using a field in the IP packet header called DSCP. And that variable basically goes and like finds the socket which are used for the file copy and data copy stages and just sets the DSCP value over there on that field. So we have sort of like native quality of service setup for clone plugin. If we didn't add this feature, what would we have done? So we would have basically done a show processes command on the donor, find the threads related to the copy process, get the sockets of the threads where the copy process is happening, and then set up IP table rules for those sockets. And imagine with auto-tune concurrency, the thread count is going to keep on increasing if we want to serve with more bandwidth. So it's all dynamic. You'll always be racing to find that particular socket and apply an IP table. So this way is better. We do it at the source itself of the socket which clone plugin starts. Okay, so before deploying to production, we, as I mentioned before in NPS, we have an optional step of doing data correctness check. So we sort of made it mandatory that we run the clone plugin and the tooling that runs the clone plugin with the data correctness check. We want to understand that if the new system is causing any sort of corruption, we want to identify this corruption as early as possible because these corruptions at a large scale is going to be very problematic. So there are two forms of data correctness that we perform. One is a pair mode data correctness, which is comparing data between the donor, where the data was copied from, the recipient, where the data is copied to. This is, if you have used PT table checksum, this is how it functions. It's just an internally written tool for something similar. We also do something, a different kind of check. It's a single instance check. It's more specific for a MyRocks instance. We basically compare data between a primary key and a secondary key also. Just the way like MyRocks behaves, we want to add that check. So I want to say that we do really thorough checking of like the data that is getting copied on each and every copy. I told you before it was not possible. We try to do with this particular new setup as much as we can. So failure in any of these checks would basically fail the whole copy. We do not use that data. So it's going to decide whether the copy is successfully done or not. And in case the copy fails, we basically go back to our currently more trusted tooling of Xtrabackup. So again, we are not going to fail a sort of maintenance from happening because the tool has some recurring bug or like it's reproducible error. We will immediately fall back to a trusted tooling which we have been using for many years. Okay, so I take away from this talk I want all of you to have is so far we have done thousands of copies over the past few months using MySQL Clone Plugin, and we have not found a single data correctness check failure. So I don't know whether all of us have like the ability to like run data correctness check like this thoroughly. So we have done this, and I really want to share that. Like so far for InnoDB and RocksDB, MyRocks, we have not seen any. It's just so far we have not seen any failure, and these are thousands of copies I'm talking about. Okay, to summarize the simplicity that we get with the MySQL Clone Plugin, like first of all, flexible tuning. The Clone Plugin provides various knobs to tune bandwidth. So if you if your copy is going to be network bound, you can basically tune using the network bandwidth that you want the copy to be using. And this can be done using a variable called clone max data, a network bandwidth variable. If you're IO bound, if you're worried about that the donor is using too much IO to do the copy to the recipient, then you can set like a limit on that particular bandwidth. So there is something called as a clone max data bandwidth variable that you can set. So both of these variables are going to push the auto-tune concurrency to adjust the number of threads that it will use to copy. Then we also have like native encryption support in the clone plugin. It's exactly as similar as we have for MySQL protocol. It's just on the clone protocol. So like managing SSL certificates, again, it's easy. I don't have to manage certificates for like 2 or 3 other tools. I just have to manage it for like one system that we use. Then finally, as you may have seen, like most of the variables that I'm sort of mentioning over here as tunables or as settables, they're all on the recipient side. This is also good. You can have multiple recipient at different times, copy data from the same donor with different configuration. So very fast storage based recipient can copy data with a higher speed. A slow storage based recipient can copy at slow speed. And none of them will have persisted that configuration. So this is a good design choice in my opinion, doing it on the recipient side rather than on the donor side. Donor is free to basically just accept however recipient wants the data to be transferred. Clone plugin also provides compression natively. Currently, it provides compression using zlib. So we are adding support for Z standard in clone plugin. This is basically again adding a couple of variables to pick the Z standard compression algorithm. And if you're using Z standard, then to use a particular compression level for Z standard. So we use compression only for InnoDB datasets because not all the InnoDB datasets are compressed, and we don't want to transfer 2 or 3 terabytes of data and burden the network. So we basically use compression in favor of that, on saving the network bandwidth and sort of sacrificing a little bit of CPU. That said, we don't use compression for MyRocks because MyRocks is already heavily compressed. Using compression for MyRocks, especially the same library, same compression algorithm, probably the same compression level also, it's just going to burn CPU cycles and not get any gains. So we transfer MyRocks data without compression.
Cool. So I'll talk about the performance and reliability of cloning process. So here's some test performance we did for the clone. From we can see that for a single thread clone, it is has a bit better performance than the single thread extra backup. And with more threads involved, the performance are getting better and better, and the peak performance achieved at 8 threads. Here's the issue and bugs we hit in the development process and test process. We have issues of direct I/O. So for InnoDB, all of the pages are 4K aligned, but for my RocksDB, the last page is not necessarily 4K in size. So we did some changes in the clone plugin to address this issue. We also add storage engine compatibility checks for the client and the donor. Now we have two transactional storage engines, so we always want to make sure the storage engines in the client are compatible with the storage engine in the donor. We hit bugs relating to WAL on different file systems and fix that. And we also have notice when for auto tune, sometimes the speed will exceed the target limit we set. There's some overshooting happen here.
So yeah, apart from the bugs, and we also identified there are a few limitations. Actually, it was really easy to identify. So kudos to Oracle for documenting the limitations in the documentation itself. And some of the limitations like concurrent DDL are already resolved in the latest releases. A couple of important limitations from our perspective that it's kind of a wish list. I don't think some of them are easily solvable, but I would like to highlight that cloning is only possible between same versions. So you have to run the same version between the donor and the recipient, and you can clone between them. This could be a hard problem to solve. I understand why that would be the case, but if at all there are no sort of like structural changes to DB or any other part which is in the clone path, and if it is possible to clone from a smaller release to a higher release, even if it is a next release, I mentioned in the changelog that it is possible to use clone plugin between version this and this would probably be useful. Again, this was, I think it's very dependent on the data structure not changing and
not really.
No?
Not really. In fact, if you go up, physically or let's say theoretically, it's possible. It's just because you restart DB and it does the upgrade. MySQL does upgrade, it's automatically upgrade.
Yes.
So it should work.
Okay.
The problem is that we are not, maybe some tests we are not making enough or something like that, but currently not. But maybe in the future it will.
Okay. Yeah, this is nice.
Going like going from I to a lower version that might won't work, but upper version should work.
Yeah, that's
It doesn't work now because it checks it and it says no way, but technically it's possible.
okay. Yeah, so this is like the most common use case would be to going to higher version. Again, you can imagine like doing a release and then sort of like using such a sort of rocket fast copy process to doing such copies and like immediately rolling out a new release. Cool. Okay, my wish list is getting completed. So another limitation. Come on, Wilfred. We can only clone one instance at a time. So this is like, again, if we had the ability to run like, again, we just talked, we don't want to do it in production, but just imagine like if having that ability that a donor can be a recipient for multiple instances at the same time. We are using multiple threads, just use more threads and sort of do parallel copies. I imagine.
As you said earlier, it's nice that it's the receiver that defines everything.
Right, so the
definer takes all the resources and another one will all the resources, then nothing happens, right? So as the donor doesn't have any clue of what's going on and cannot auto-tune anything, it won't work.
Yeah, so the design choice that we had described before is sort of like blocking this. Yeah, so in my mind, like scaling topologies horizontally is far more easier. This way, just fire one command at the time of the day when you want sort of like, you have increased demand and you want to add more replicas, read replicas. Doing something like that, or like doing a large schema change, like just do it on one host and sort of like propagate the schema change to all the other hosts by creating like.
And I think also for the redo log, you have an issue because you subscribe to consume the redo log, and you appoint always the LSN and advancing to be able to free the
redo log.
But if there are many, you should have to take the lower one, but I think it's not prepared for that.
Yeah, fair enough. Cool. Well, those are the only limitations that, like, again, it's a very like subjective perspective here for me that we wanted. Sorry, question?
When you say cloning multiple instances, it's a limitation. You are talking about multiple replicas out of the same donor, or if you have multiple instances, MySQL Fleet on the same machines, can they run in parallel?
Oh yeah, so this is about one donor and multiple recipients trying to like sort of like get copied. Well, that's what we had, and like if you have any questions, we can do sort of a Q&A again. Like there is a question here.
So my question is about your benchmarks, where you showed that extra backup was 1x and then thread, and that's one. Is that extra backup single threaded, or did you run any extra backup benchmarks with multiple I/O or compression threads or anything like that?
Setting is a single thread.
Extra backup, you didn't know, like.
We could, so as I mentioned, like in the previous slide, the moving parts here for a extra backup copy. So it was XB stream as the copy format, Z standard as the compression, and the socket pipe for the encryption. the socket pipe unfortunately makes encryption a single-threaded operation. So no matter how many threads we use on the extra backup, we are going to be throttled by the encryption throughput on that socket pipe. We could actually use multiple thread and sort of like move encryption, but that's also a requirement that a protocol should have some sort of encryption. That's why like the native encryption in Clone plugin helps. It's if we are going from one DC to another, we are expected to have a socket pipe or some sort of tunneling that is encrypted. So that's why like this is what is the advantage for Meta in this? And it's like, yeah, use clone auto-tune concurrency and get like blazing fast copy speeds.
Yeah, Simon from Booking tested it because they were using Xtrabackup also for Booking, and he blogged about it. It's almost, he tested multiple threads, it's almost every time at least twice faster.
Nice.
So, you say clone 8 is 6.3x. Is that simultaneous clones? Or?
That's like clone using 8 threads. So yeah, the best advantage is like over like our current configuration of Xtrabackup is clone is multi-threaded, and it's multi-threaded in a place where like we are not limited by that socket pipe being sort of like single threaded. So that's the advantage we get, and it's also like what results in like faster speed. Any more questions? Nope. Well, that's all, folks. Thank you for coming. Thank you for attending. I have attended the conference after 4 years. I'm so happy to see people in person at the conference. So thank you for your time.
Thanks.